In this video, we're going to be looking at the electronic configuration of atoms. An atom is made of a central nucleus containing the protons and neutrons, with the electrons orbiting the nucleus in shells. There is a limit to the number of electrons that a shell can hold. The first shell can hold a maximum of 2 electrons. The second shell can contain up to 8 electrons. And the third shell can also contain up to 8 electrons. When drawing electrons, after you get to 4 electrons, start to pair them up. Electrons always fill the lowest energy shell first, which is the shell closest to the nucleus. There is a clear link between the periodic table and the electrons in a shell. For example, the first period contains 2 elements, and the first shell can hold a maximum of 2 electrons. So, we can see a hydrogen atom with 1 electron, and a helium atom with 2 electrons. Now that the first shell is complete, the second shell starts to fill. The second period of the periodic table contains 8 elements, and the second shell can hold a maximum of 8 electrons. So, we can see a lithium atom with 3 electrons, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon with a full outer shell of 8 electrons. Now the second shell is full or complete, the third shell starts to fill. The third period contains 8 elements, and at this level, the third shell can hold a maximum of 8 electrons. So we can see a sodium atom with 11 electrons, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon with a full shell of 8 electrons. For the fourth shell, we only need to apply this model to potassium with 1 outer electron and calcium with 2 outer electrons. Electronic configuration tells you how the electrons are arranged in the shells around an atom. You may also hear it called shorthand notation. We will use hydrogen, carbon, and sulfur as examples. Electronic configuration is given as a series of digits. The number of digits tells you how many shells there are. For example, hydrogen has 1 shell, so it will have 1 digit. Carbon has 2 shells, so it will have 2 digits. And sulfur has 3 shells, which means that it will have 3 digits. The actual digits tell you how many electrons are in each shell. Hydrogen has 1 electron, so it has an electronic configuration of 1. Carbon has 2 electrons in the first shell and 4 electrons in the second shell, so it has an electronic configuration of 2,4. Sulfur has 2 electrons in the first shell, 8 electrons in the second, and 6 electrons in the third shell, so it has an electronic configuration of 286. The digits should always add up to the atomic number. In part A, you are being asked about a potassium atom, which has an atomic number of 19. Since it's an atom, the number of protons equals the number of electrons, so a potassium atom has 19 electrons to place. Remember, each shell can hold a maximum number of electrons. So, there will be 2 electrons in the first shell, 8 in the second, 8 in the third, and 1 in the final shell. An answer of 2881 gains 1 mark. In part B, you are being asked about a nitrogen atom. A nitrogen atom has an atomic number of 7, and since it is an atom, the number of protons equals the number of electrons. So a nitrogen atom has 7 electrons to place. This means there will be 2 electrons in the first shell, which leaves 5 electrons for the outer shell. The correct diagram gains the mark. For both questions, the number of electrons should add up to the atomic number. Horizontal rows of the periodic table are periods, and vertical columns are groups. Each group is linked to at least one number, which is usually found above the group. For example, group 1, group 2, group 7 or 17, and group 0 or 18. Some groups have specific names. Group 1 are the alkali metals. Group 2 are the alkali earth metals. Group 7 or 17 are the halogens, and Group 0 or 18 are the noble gases. As you move down a group, the number of shells increases by 1. But elements within the same group have one thing in common. All the group 1 elements have 1 outer electron. All the group 2 elements have 2 outer electrons. All the group 7 elements have 7 outer electrons. And all the group 0 elements have a full outer shell of electrons. This is what makes them unreactive. Although they can be referred to as group 17 or group 18, this does not mean that the halogens and noble gases have 17 or 18 electrons in their outer shell. Part 1 asks for one similarity and one difference across a period. A period has the same number of electron shells, for 1 mark. Since the elements from lithium to neon are in period 2, you could also say that they have 1 full shell. The number of outer electrons increases by 1 as you move across the elements from lithium to neon, which means they have a different or increasing number of outer electrons. This gets the 2nd mark. The word outer is not necessarily required for the mark, but you should put it in your answer. Part 2 asks for one similarity and one difference down a group. A group has the same number of outer electrons. This gets the 1st mark. Since the elements from beryllium to strontium are in group 2, you could also say that they have 2 outer electrons. The number of shells increases by 1 as you move down the elements from beryllium to strontium, which means they have a different or increasing number of shells. This gets the 2nd mark. You could also use the phrase energy level to replace the word shell. For both questions, there is no need to explain your answer. Electronic configuration is a way of writing or drawing how the electrons are arranged in the shells of an atom. The first shell can hold up to 2 electrons. The second and third shells can hold up to 8 electrons. When it is written, an electronic configuration is a series of numbers. The number of digits tells you how many shells there are, while the digits themselves tell you how many electrons are in each shell. If elements are in the same period, they have the same number of shells, but the number of outer electrons increases by 1 as you move from left to right. If elements are in the same group, they have the same number of outer electrons, but the number of shells increases by 1 as you move down the group. Don't forget to check out our other fantastic resources here at Save My Exams.